Okay, we're on. Give us a wave, red headphones. All the way at the back, Springwise crew. Get your headphones on. We're on. We're away. Okay. Welcome back, everyone. So, pitch and invest stage, the most important stage. My name's Ben from Raaise. Here we go, this one here. Raaise. It's got 2 A's in it. It's a domain issue. Raaise.co. We're Australian, so you can say it Raaise. I'm not Australian, but we are. And we do AI-powered matching between founders of impact startups and investors. Impact investors like these wonderful people. So we're trying to take the pain out of that. So if I can help you with that, especially founders, come and scan a QR code with me afterwards and you can get some instant matches and see if that works if you're fundraising. Oh yeah, potential money behind a QR code. So we're on to our second session. How this works is we've got 27 startups pitching across 9 sessions, down from over 100 startups that entered. And then we've got 3 going through from each of these, pitching at each of these sessions. We might even squeeze in 4 in this one. And then the judges will have a chat with all of them, and the judges will pick 1 to go through to the final tomorrow. That's it, nice and simple. But before we meet our first startup, it's good to say hello to our judges, because investors often are seen but not heard in these things, and it's really important. Ultimately, they're going to play as important roles as the startups in making this thing a success. So welcoming Surakat from Green Angel Ventures, and Nick is like, Matt is late. He's on his way. Nick from Elbow Beach. Nick, starting with you, how did you end up in your role, and what does Elbow Beach do?
Hi, Ben. No, thanks for the introduction. So I'll start with my background, and it'll make sense. So my name's Nick Charman. I'm one of the founders of Elbow Beach. I actually came from a background of property development and investing across all sorts of very boring verticals. About 8 years ago, I started impact investing, small tickets. Some of them did okay, made a lot of mistakes before coming together with my other 2 co-founders. One of them's a scientist and one of them's a very, very, very good board level PLC guy. So he really knows what he's doing with commercials. And we realized that from my mistakes, what was actually happening was, we saw these companies, particularly in the tech space, but there was a real gap of commercialization. So the 3 of us came together to form Elbow Beach about 3.5, 4 years ago. Since then, we've almost fully deployed our first fund, just a few follow-on tickets, and we've just closed our second fund from the British Business Bank cornerstoning us. So we primarily invest in climate technologies. We go straight for the hardware. That's why we've got Tom, our sort of resident caged scientist, on board. He's in-house due diligence. We just find it's a lot quicker. And then we really try and build we've got like 10 of us now, really try and strong commercial focus. We all come from running companies, having companies ourselves. We brought on a decent finance chair who has some idea of venture capital, not like the rest of us. And we just see these amazing founders, and I'm sure we're going to see more today. But if you've got a PhD in whatever and 30 years of chasing that, maybe you didn't get 30 years in the nasty, horrible business corporate sector. So that's the gap we try and fill. So
after the real scientists, what's in the name, Elbow Beach?
Okay. So the short version is the 3 of us as founders, when we were all chatting, we realized we'd actually all been on Elbow Beach together. We tried not to go with a name that had already been taken, should we say. We wanted something a little bit unique, but also we use it as a bit of a canary in a cage. So, I've got family over in Bermuda. We've all been out there. Tom, our scientist, has lived out there. Elbow Beach is this beautiful, beautiful beach there, which is being hammered by climate change. There used to be a tiny little kind of bar coffee shop there. They don't even bother rebuilding it anymore. The storms come in, they smash it up. Bermuda's a wealthy island. They have banking, they have insurance, but it's always the locals and the guys that and the girls that work in these places that just don't have a job anymore. Tourism's on the floor. COVID didn't help, so we're using it as a bit of a canary as a cage. 20-year storms become 5-year storms. Just takes the beach out. So, we hope that our grandkids will be there one day, but we'll do our best to make sure that's true.
Now that symbolism and story really helps connect us back to why we're doing this. And just 1 or 2 examples of recent investments that you're excited about.
Okay, so our first portfolio, we sort of split up a bit, but the main tickets were across decarbonising technology. So we did everything from an electric vehicle producer, but they try and, if you guys have ever heard, or you haven't heard of it, look it up, because I think they're cool. Monroe, so they do these massive 3.5-ton EVs that are electric. Just as a bonus, they accelerate about as fast as a Porsche, but they weigh 3.5 tons. So, it's always nice to get in one of your investments one day. So we're looking to decarbonise construction, mining industries. We've invested in a company, I'm trying to pick a few very different ones. We invested in something called Anaphyte. They make cathode active material for batteries. Doesn't sound very exciting if you don't really know the industry, but they can make batteries about 10-15% cheaper and 10% better. You stretch that out across all the EVs in the world, it's a big difference. Yeah. I chair one of our companies called Ally. They use, it's a bit of competition at the moment, but they use reused Tesla power packs, things like that, to replace diesel gen sets. So we're looking to circular economy there, decarbonising industry, bit of energy resilience. No, I think that'll do for that.
Ally is the best looking aesthetically power pack I've ever seen, for sure.
They have the best graphic designer.
They do, they do. Surakat, welcome back. Good to see you again. Tell us about Green Angel Ventures. I know you're here with a colleague as well. What are you up to and what's your role?
Yeah, so I sit in the investment team at Green Angel Ventures. So I'm an engineer by background. So I've been in the startup and spin-out ecosystem for a good 7 or so years before coming over to the investment side of Green Angel Ventures. But we invest across the UK in companies that are tackling climate change, portfolio of about 50 companies, and we invest from 3 pockets of money. One is our members, so we've got what we call Green Angel Syndicate, so it's a group of high net worth individuals, family offices, sophisticated investors who we bring together to invest in these companies that are actively trying to tackle climate change. Then alongside that, we've got 2 pockets of money. One's from the British Business Bank, the original angel fund, and the other one is our climate change fund, so it's an EIS climate change fund that also wants to invest in this companies tackling climate change. So we deploy money from all 3 pots into these companies, and so we invest across. We're quite sector agnostic as long as there's a clear evidence in terms of companies that are how you can clearly articulate how you're tackling climate change in terms of what your business is doing.
Fantastic, and again, exciting investments that have been made in your mind.
I mean, the last, few months, we've done 2 quite exciting material companies. One's Ada Biomaterials, so they're extracting protein out of brewery waste, and they use that to make new leather, which is equally as good as leather, fully
What's
sustainable.
What's the name?
Ada Biomaterials,
okay.
ARDA.
Ada.
Yeah, and then the other one is one called Carbon Cell. So they've got something called expanded carbon cell, which replaces expanded polystyrene. So you're basically applying heat to pellets of char, of biochar, which then expand into a foam-like structure that you can use as packaging as well, so replaces polystyrene. Maybe Salvalco is an existing portfolio company, which they replaced butane, propane, LPGs that you have in your aerosol cans. So replacing that by using their new innovative valves, which allows you to just use inert gas and nitrogen, and you can also put double the actual product in the canister. So it's a lot more environmentally friendly in that sense.
Amazing. And this is why we love engineering manufacturing. It's real, it's tangible, and there's been a SaaS takeover for a long time, and now we're coming back strong. And AI and SaaS is hard, right? So final quick question, then we'll go to our first startup. When you're making decisions about investing in manufacturing and engineering, is it any different to how you think about SaaS or software?
To a certain extent, I think for us, when we're making this decision, I think the team is usually very, very key. I think we want to see within the team, do they have the right individual, the right expertise that can really help them scale this up? Because we see probably a lot more complex and takes a lot longer than you would in terms of within the SaaS, within kind of, if it was kind of a SaaS business. So I think we critique that team a lot more in terms of that key expertise on the engineering side of things.
Yeah.
Cool. I think that's a really good point, Surakat. I think for us, it's the time. It's just that simple. You do hardware, it takes longer. Even if you've built the damn thing, the procurement cycles for the large companies. I mean, we were doing a customer call with, careful with NDAs, with somebody the other day, and they said, "Oh yeah, well, we're looking for it for our net, two cycles time." So you do the maths. It's 5.5 years time before you can even look to get it into a customer for a trial. With the standard fund life being 10 years, you might have found them 2 years in. You're running out of time. It's super hard. So it's a real challenge, and it's something that I think we need to be a lot sharper on as investors, and trying to get that value add in there to really try and speed those up.
Yeah, absolutely. Thanks, guys. Okay, so let's hear from our startups. No, give us a wave at the back. Nice to see you. Springwise, yes, there you are on the back row. Yeah, nice to see you guys. I mean, the business started in 2002. It's amazing. So first up, we have Alexis from Synchrostar. Alexis, let's just check you've got your deck ready. I want to make sure you're happy before we go. So the way this will work, thanks, Chris, for helping with everything. Chris organised all of this over the last year. We just turn up on the day and have fun. Chris has done the hard work. So we're going to have a 4-minute pitch from Alexis and then a few minutes chat with our investors, and then we'll move on to the next one. Awesome. All yours, Chris. Sorry, Alexis, all yours.
Hey, thanks a lot. So I'm Alexis, I'm the CTO at Synchrostar. We're based in Edinburgh in Scotland. So I'm talking today about one of the biggest decarbonising challenges of the time. So industrial heat is one of the big issues. So industrial energy needs about 60% to generate heat, and that heat is at the moment mostly produced with fossil fuels, 75%, and that represents 20% of global CO2 emission. So very large legal problem. The way to deal with that problem is to electrify industrial heat, but you have 3 major issues. So there's actually no technology for a large part of the market, particularly at higher temperatures. Issues with grid connections, so no enough electricity on site to provide the electricity, and the highest power gap to the electricity price versus cost of gas is too high. And therefore the value proposition of electrification is difficult. So the solution for the electrification of industrial heat is heat pumps. That's probably one of the things people can agree on. And the reason is that heat pump can use waste heat to generate high-grade heat. They actually don't need as much energy. They have a coefficient of performance of 3. So 1 unit of electricity would generate 3 units of heat. But they can also produce heat and cold at the same time. They can also interact with energy storage to add flexibility and therefore reduce the demand when electricity is expensive. And of course, with the high coefficient of performance, they reduce the amount of electricity required by the grid. Therefore, a smaller grid connection is required. So the problem of heat pumps is they're actually, so they're meant to be an animation there, but they're actually not able to reach temperatures above 100 degrees C, 120 degrees C, and that's limited by the compressor technology available on the market. There's actually no compressors able to go to these higher temperatures. So Synchrostar is developing an oil-free compressor able to reach temperatures of 400 degrees C, and that covers about 30% of this industrial heat market with high temperature lift. We're capable of expanding gas and recovering energy, and that gives us a higher coefficient performance at higher temperature application. So we think we can have a really good value proposition for heat pumps beyond the 100 degree, which is the current limit. Whoops, sorry. So we've got a strong team of dedicated engineers. We're based in Edinburgh in Scotland, 25 employees. A lot of our team actually have long experience of manufacturing radial piston machine for the hydraulic market. So we've brought technology from low TRL to TRL9. Our technology is protected by 4 patent families, so the compressor expander, but also on system and application. And so far we've received about £1 million of equity, but we've reached £11 million total investment through a contract from the UK government. So it really allowed us to move very quickly into the field. So the company was founded in 2017, but we really started growing in 2023 with this. So basically in 2 years, we developed our first product, a 1.5 megawatt compressor useful for heat pumps. That machine is now operating at 400 degrees on our 200 kilowatt test rig, so really working in realistic operating condition for industrial heat decarbonization. We're looking for the next phase of investment to bring the technology to TRL7, MRL7, so manufacturing readiness level 7, which is very important. So total budget about £12 million. Because we cover all the important topics of decarbonization, we can actually leverage this investment by government funding and grant opportunities. So we think we can have a 2 times grant multiplier. The aim of this next phase is to mature the technology, so both technology, so be able to demonstrate performance and reliability. Also, can we manufacture this machine at low cost, and can we enter the market? So we're aiming to have our first demonstration project as soon as next year with potential partners, aiming to targets licensing revenues in the future, working with large manufacturers to produce this machine at large scale in different regions of the planet. There we go.
Thanks, that's fascinating. So I think my question is about, you did mention the spark gap, and I understand that you may not want to share all the details of your licensees and everything else yet, but where's your first customer and who's your ideal customer, given the spark gap?
Yeah, so the spark gap is actually improving very rapidly because of renewable penetration. So Europe is a very good market for heat pumps, particularly Germany and Northern Europe. So the spark gap is already really low at the moment. So our best customer at the moment, our beachhead application, would be drying application, which is in the range of 20,000 systems per year for our machines. And we have a very high coefficient performance for those, above 3. So we expect a payback time of 3 to 4 years with prices of 2024. And actually there's been an announcement from the European Parliament to support decarbonisation of heat with 1 billion of investment on basically heat pumps. And that's just been announced this week. So very large incentives from the EU market to bring new technology on the market.
Perfect. Just one quick fact. Is it drop-in? Is it drop-in tech?
It can actually, yeah, it can be. So ideally, actually, is retrofitted to gas burning technology. So it can be fitted in parallel. So you can keep your gas boiler as a backup solution. Also, in the transition to use the gas in expensive electricity prices, you can still use gas, for example, peak time in the evening. That's a possibility. But having a backup solution, that's the norm in industrial applications. So you have a backup. You tend to have 2 gas boilers anyway, so you remove 1 gas boiler and fit one of our systems.
Cool, thanks.
Hi, Alexis. Very good presentation. I guess first question for me, I think if 11 million has been spent to date, I guess what's been the key technical hurdles you've had to overcome in that time?
Yeah, actually, this investment, 11 million pound, was for about 30% for the compressor expander, so about 3 to 4 million on developing this compressor. So there's a lot of technical challenges. I would say the sealing of the gas piston is a tricky part, but we've now demonstrated that the technology can work. We've also used a large part of that funding for application engineering, so how to use this type of machines for industrial heat application, but also energy storage, like pump thermal energy storage application. So a large portion of the money was spent there.
And just a separate question here, in terms of your competitive advantage, because I guess in terms of your coefficient performance of 3 at the moment, but you have a number of other competitors who are offering that in the heat pump space as well. So I'm wondering, what else? I mean, we've mentioned a few things here, but what else is that competitive advantage that you have again in this space?
Actually, there's very few competitors in the higher temperature applications. So conventional heat pumps will limit at 120, 150 degrees. That's the maximum that technology can reach. So there's a few, maybe 5 or 6 startups developing new product for higher temperature. They're focused on steam generation, while we think our application is more suitable for drying application, which needs a higher temperature glide. So we think a market which is actually not covered by any technology on the market.
Sorry, I may have missed the market size. What do you think you can reach with that? Sorry, I was scribbling furiously.
So the market for industrial heat, from our point of view, is infinite. But so the beachhead market for one customer is about 10,000 units per year. So for one of our compressors. So 10% of that 10,000 units per year would be about a turnover about 300 million just on the compressor expander manufacturing and sales.
And does your tech allow you to service all of that?
Yes.
Yeah, yeah, sorry, I just, you mentioned drying as opposed to wet markets, wet heat.
Yeah, so our application can be applied to a number of different industrial heat applications. So the majority of industrial heat is steam-based, about 70-80% is steam-based. So we can also produce steam, but we think our best value proposition is on drying, and it is not covered by any other technology on the market, and the market is big enough to justify the investment.
So can I just replay what I think you said, which was you can do all of it,
yes,
but you're going to go to the bit that no one else can do.
Yeah, and that's the best value proposition. Yeah.
Perfect. Great. Thanks.
Thank you, Alexis. Big round of applause. Well done. I felt those questions were building some heat there. We could have kept going. I know, but we're going to keep moving. So next we're going to have, I believe, a pitch with a translator. We have an international team. This is exciting. So please welcome to stage Kaz Industrial, the team. And let's make sure we've got this ready. Yeah, keep your headphones on so you'll be able to hear yourself. Fantastic. Okay, great. I'm going to take your mic, Surakat, if that's okay, so they can share. There you are, sir. And okay, so I'll just wave at you. You've got 4 or 5 minutes. Off you go.
Добрый день. Hi. Меня зовут my name Amankelde Ristan, Kaz Industrial Engineering. Нашу презентацию будет делать Тамира.
I'm going to do the presentation. I'm going to help him to translate it. Hello, everyone, and thank you for having us here today. Today, we're going to introduce our completely new type of clean energy called the electric generator. So the problem, 50 years after Kapitsa's 1975 statement, alternative energy is still uncompetitive. Wind, solar, and geothermal remain marginal in global energy. It is impossible to stop global industry with the sanctions. It must be provided with a sustainable source of clean energy. Centralized grids are vulnerable. High transmission losses and costly infrastructure remain. The solution. Intensive generation of electrical energy from polar molecules under resonant polarization in a dielectrical medium. Generate electricity without fuel, combustion, or emissions. Autonomous, silent, no moving parts, and safe. Comparable in cost to gas generators, low operating cost, decentralized, and scalable. How does it work? Similar to a laser, but with magnetic fields. Resonance creates powerful alternative magnetic fields, converting into electricity via electromagnetic induction. No rare or toxic materials, no waste. Clean output 380 volts per 50 hertz. Development status. TRL4 completed, concept validated via lab and prototype. Verified by Professor Insep of Purdue University. Our achievement, scientific concept defined, prototype built, lab stimulation and tests successful. Roadmap and funding. Stage 1, experimental generators in 6-8 months, investment £300,000, goal TRL7. Stage 2, 100 kilowatts unit, cost £2,000 per kilowatt. Energy cost 2-3 pence per kilowatt. Space 100 meter cube per equal 100 per kilowatt. Includes maintenance and warranty. Strategic advantages. Energy independence near point of use, immune to grid and geopolitical disruptions, massive CO2 reduction, no lithium, cobalt, nickel, or rare earth metals. More cost-effective than solar or wind. Join the future of energy, seek an impact investor of strategic partners, and yeah, basically.
Okay, yeah. No. Thank you very much, and thanks very much for the presentation and the translation. I guess the first question I have is, what have you, in terms of how many kilowatts have you proven this to? And also, I guess, what are the risks you envision in getting this to the 100 kilowatt, I think, from the presentation there. So what scale have you proven this to, and what's the risk you see in getting it to TRL7?
Создана небольшая установка лабораторная. Это не киловатт, это вольтах маленьких.
In a volt. Okay.
Не Киловатт, а ватт маленький.
So it was just like a little
Laboratory.
prototype was made in the lab, but not in the.
Это 4-й уровень развития ТРЛ-4. Это небольшие установки. Небольшая установка.
So we've got a technical integration risk about scaling from lab setup to working prototype, then engineering complexity, and also a funding risk because without required this 300,000 pounds, progress may be delayed, and about validation and certification. So that's the risks.
Okay. And can you elaborate on the can you tell me more about the certification that you need?
Какая нужна сертификация для продукта?
Ну, на данном этапе не нужна. Мы находимся в технопарке Алатау. Мы специализируемся на инновационном деятельности, и нам не нужна сертификация, а в дальнейшем эту продукцию надо будет сертифицировать как генератор.
So the company is located in Technopark, so we don't need a certification for make a prototype and etc. So we're on a stage of making prototype, and we are seeking investment for making it to TRL7. So we are in this stage right now.
Thank you.
How confident are you in the, if you're at TRL4, in your capex and opex in terms of the, how confident are you in your efficiency and your ability to compete with the incumbent technologies? Does that make sense?
Насколько вы уверены в том, что у вас достаточно компетенций, чтобы бороться с конкурентами? Насколько вы думаете, насколько ваша технология
Конкурентоспособна. Но это новый класс энергии. Мы конкурентоспособны на данный момент. Вот по этой таблице видно, что наша энергия лучше всех тех, что имеется на сегодняшний день. Да, и
So the main part is what makes us competitive. It is a capacity factor. It's more than 95%.
Скажи, что она лучше, чем любые другие ресурсы.
And it's
любые известные
more
на сегодняшний день
efficient
технологии
than
лучше.
any other energy sources.
Have you, how far has that got? Is that what you're doing today in terms of the efficiency and, or sorry, the capacity factor, or is that a projection?
Это то, что уже сейчас существует, или вы только думаете, что это так будет?
У нас есть лабораторная установка. Уже мы прошли 4 этапа, так что мы уже большую часть пути прошли.
So I think it's more like what we are waiting from this project.
Sure. Yeah, I can clarify the question. So obviously at a small scale, are you seeing these percentages? I understand obviously there's a tech risk and you have to see what it does when it's 10 times the size, but when it's in the lab, do you get these numbers?
Откуда у вас гарантия того, что ваш прототип, который у вас будет в будущем, побольше, который, что он точно будет работать на то, как мы хотим, вот 100 киловатт в час? Откуда гарантия того, что, потому что прототип сам маленький был создан?
Да. У нас есть лабораторный образец, и у нас есть обоснование, научное обоснование. У нас есть фундаментальные законы, так что мы на 100% уверены, что это получится.
So it's more like theoretical. We got a validation from scientists who is in SEPA from Purdue University, and we created prototype in a lab. So we got these proofs from the more like from
Мы
a lab.
10 лет занимались научным обоснованием.
So we work for it for 10 years.
Okay. Thank you.
Kaz International, thank you very much. Thank you very much. Thank you, judges. Well done. Always an extra challenge doing with translation, but we managed it and we learned something new about a new business, which is great. Thank you for being here. So next up we have Matt from Axel. Where's Matt? Is this Matt?
It's Ben.
Huh? It's Ben. Ben, I apologize. From Circular 11. Excellent. All right, it's all good. We've got you here. Just got in the wrong order. Let's get your deck up and then we'll get into it. Jumping around, but that's what we're doing on the fly. Okay. I just see red ears in the darkness. It's like some weird sort of deep sea documentary, but you're not moving around or eating each other. Okay, we're good to go? Okay, please welcome Ben from Circular 11. Here you go, Ben. Round of applause. Let's go. Let's get some energy. We can hear the claps. Thank you, everyone.
Thank you very much. Great to be with you both, and thank you all for staying. I'm before lunch on the graveyard slot, so I'll try and be super efficient. But yeah, do appreciate your time and your attention. My name's Ben. I'm the co-founder of Circular 11, and we create carbon-negative composite materials from unrecyclable plastic waste. And we do so in order to meet the billion-ton-a-year timber shortfall that's expected by 2050. Now, this company came out of a waste management project in Nepal, where I met my co-founder, and we went to bed each night with the smell of burning plastic in our nostrils. This is how the families we lived with, like 30% of the world, had to deal with their plastic waste. So we wanted to come back and find waste valorization technology that we could take to a country like Nepal. It wasn't until we came back that we realized we're doing pretty much the same thing here in the UK. So of the plastic that reaches a recycling facility, about 90% will get sent to incineration. That's a more carbon-intensive form of power than coal power plants. The number one reason for this is that there are tens of different types of plastics which are very difficult to separate. There are hundreds of different grades within each type of plastic. There are thousands of different additives within each type of grade. So the reason why plastics are good to produce is because you can tailor them. But that's what makes it a nightmare to recycle with. You will always get these very large mixed waste tranches. You can't chemically recycle them. You can't mechanically recycle them. But I want to contrast this with a crisis of a very different sort. Whilst there's an overabundance of plastic, there is a crisis in timber supply and other building materials in adjacent spaces. Timber demand is tripling over the next 25 years. It takes a long time to grow a forest. There's climate stresses, and most importantly, timber preservatives have been banned over the last 15 years. Creosote, CCA, arsenic, all of the major ones have been phased out. So timber assets are lasting about 5 years now, 5 to 7, whereas they used to last 30 years. So we've got way too much material in one space, we've got not enough in another, and we do something very simple on the surface. We turn unrecyclable streams into high volume construction materials that can act as an alternative to this. So it's a pretty simple and humble product. It's a plank, but it lasts 3 to 5 times longer. It directly mitigates carbon. And most importantly, we're reinventing the cost base in the manufacturing sector that we're in. We have less than half the manufacturing costs than our competitors because we take waste that has no value or has a negative value. We get paid to take it. The reason we're able to do that is because we use machine learning within our manufacturing line. We ingest real-time characterization data and we feed it into models that we've trained to adapt processing parameters and formulations constantly in real time in order to compensate for input changes. And what that basically means is we can take a much wider range of plastics. The margin that we have is much wider than most manufacturers, and we can create a high quality of output from it. This, unfortunately, sorry for the unprofessionalism, is a read deck. I thought that I'd sent clearly the wrong deck. So maybe the most important things, if you don't mind me skipping, is it's a huge market. Timber is a $250 billion market. We can sell at a much lower price than our competitors in the plastic lumber space. We can reach timber price parity. That unlocks a very different kind of contract. And we're already doing this. So we have maxed out our current factory. We demonstrated this over the first 2 years of the company's life by making structures from the material, but now we're a high volume supplier. So we've maxed out at £300,000 a year. We are trying to move into a facility that's 11 times bigger. What else to say? We're a team of 10. We've got £2 million in traction. That's from a range of national decking, national furniture, and infrastructure contracts. We've done 12-month trials with national highways. We already sell to councils. We've got past a lot of regulatory barriers that stop other plastic lumber manufacturers from positioning in this space. And we have already put down £100,000 worth of deposits in industrial machinery, so we are ready to move in October. Our customer contracts are ready to scale up so that we can get into profitability in January. And we're ready to go. We just need funding for that. Maybe just a note to end on. I'm sure I'm overrunning, sorry. But our vision is that plastic and composite manufacturers can and must reach the same scale as the global timber sawmill companies if we're to meet the major resource challenges of the 21st century. We have a very ambitious growth plan over the next 10 years. We want to reach £250 million in turnover, and that's just the start. So really excited to be with you all. Thank you very much for your time.
Quick question. So your business model at the moment seems to focus on, well, I think you said it focused on your raw materials being free. What happens if that changes? Because there's two factors. I'll just qualify the question. There's two problems that you could potentially see. One is you still have to pay to go and collect it.
Yeah.
And two, traditionally when things that are free or waste actually have a market, someone will go, you're getting a big margin out of that, we'll have some of that.
Yeah. Good question. The simple answer is that we don't count on it being free. We model for an input cost of about £150 a tonne. We model for some amount of valorization. In reality, I would say there's in 2027, incineration's becoming a lot more expensive. It's getting carbon taxed, and it's going to become mandatory for councils to collect plastic film. So we're going to see in excess 500,000, 750,000 tonnes of plastic film. There's no end market for that film. So I don't see a huge supply crisis, but it's for collection costs, for the fact that you have long-term partnerships and they want to valorize their waste streams. It's reasonable to say we're going to pay a little bit for it, and that's fine if they do. We get paid up to £600 a tonne right now, but we're not on our financial model saying we'll count on that.
Good answer. No, excellent. You'd be surprised how many times you get a blank look when you ask that question. Is there anything that your product can't do compared with timber? Because it's a very different kind of substance, isn't it?
Yeah. There's a reason why we're going for outdoor material. That's about 50% of the timber market is in outdoor assets. That includes pallets, that includes cladding, shelters. But we don't want this to be in a roof span or something like that. The basic reason is, even if we layer and reinforce our plastic with fiber, it's not, timber is so stiff. It's really stiff. So for a 3 meter length for our materials, it's great. You won't notice a difference. It can be used in decking. But if you see major construction projects, I mean, cross-laminated timber, it does amazing things. And so our thesis is very much, timber's good. We don't want to replace timber, but there isn't enough of it, and we shouldn't be using it in low-grade applications like fencing, like decking, like pallets, like scaffolding boards, sleepers, things like that. Our material can be perfect, and the market's large enough.
Very good presentation there, Ben. You'd mentioned about being able to use a wide range of plastics and your multi-polymer blending. So I'd want to know a bit more in terms of consistency of your product in terms of you've got kind of an inconsistent waste stream, you're using a wide range of plastics. So how do you kind of account for, and how do you make sure that your product is then consistent?
Yeah, it's a crucial question, and as my material scientist often reminds me, we're not doing magic here. It's not alchemy. We do have supply constraints. We don't take anything. But each waste supplier tends to have waste streams that vary within a certain bound of parameters, and we can formulate within those parameters. So if there's a little bit too much plastic film, or if there's a little bit of polystyrene entering the waste stream, that's okay. We can reinforce it. We can combine it with a little bit of stiffer polymers. We can do compatibilizers for the polystyrene. We can adjust within the bounds that we have for our suppliers. I guess the short answer is we do a lot of work to onboard our systems before we have a new supplier. It's not quite as simple as we just pop some new stuff in.
And the other question, I guess, is what's the end of life plan for your product?
We recycle it. There's an obligation that comes with me saying this. We recycle it. We've invested in the infrastructure. We've even invested in the collection infrastructure so we can come and collect it. But this will be around for 30 years. I'd love to exit in 5, even if it's 8. I don't plan on being there in 30 years, and a lot of the people we talk to won't be there in 30 years. So we need to really work with customers so that we know that because it can't be recycled before us, it certainly can't be recycled by someone else afterwards. We need to be the one taking it. But reverse logistics has to be the way that complex materials get recycled. We're part of that. Thank you. Thank you very
Fantastic.
much.
Thank you very much.
Hey.
Good job. Well done. Thank you,
Thank you very
everyone. Okay, do we have Matt from Agsol? Is he here? No? He's not here. Matt from Agsol, you're missing out. So, judges, you have seen your 3 pitches. You've got 3 minutes.
I don't want to create it.
Oh, yeah, we're going to have that crossover. Thank you. So, Chris, can we get this back on the judges' slide? Thank you. And judges, you've got 3 minutes to have a chat. Keep the mic away about who's going to go through to the final. Is anyone here working on a business startup that they want to share really quickly? That you've got 30 seconds. This is your chance. I'll come down with a mic. See if we can make that happen. Anyone here? Give me a wave. No. No one wants to pitch their big, bold, exciting idea. Okay, no problem. So we are going to wait for our judges. We've got 2 minutes, and then the final is tomorrow at 2:30. We've got 5 more sessions after this, 2 this afternoon, 3 more tomorrow, and then we're going to have the final over there with Lucy Siegel, who you remember has been broadcasting about sustainability, I think, for over 20 years on the One Show and many others, raising these kind of issues and solutions for a long time. How are we doing, guys? Bit more time. If anyone is also looking to raise money, this is what I do, Raaise, 2 A's, Aussie, look up raaise.co. As you can now just put if you're running a business, you put your startup in there. If you're fundraising, and the AI will automatically take all the data it can find on you online and start matching you with impact investors on 6 different sectors and variables. So it's a really quick way to start to see who might be matching by. So if you haven't raised as a startup in the past, this stuff takes time, and suddenly you can be running a big sales funnel for raising money as well as your own sales and marketing funnel for your business, and it can overwhelm small businesses. The fundraising journey sometimes sinks businesses because they get so distracted by it. So we're trying to help solve that problem in the sustainability space along with many others. So get on to Raaise and see if we can connect there. All right, guys, how are we doing? I'm going to do one more ad break, and then I'm coming to you. The other ad break, who here has integrated AI into their business? Anyone? All done, sorted, trying, getting beyond prompts? Excellent. So I found that this was a problem with my business, and something else was just trying to build our own AI literacy as non-technical founders. And so I found someone who was really good at this, Shen Solon, and she was an AI builder with a platform called Launch Lemonade, and I went to her workshop and I said, can you help me run workshops for my community, which is impact and sustainability founders and investors? And we started doing this, and we did these 1-hour workshops, and the people were like, this is great, but I can't do this in an hour. I can't set up my agents for my sales and marketing, for my operations, for my impact and all this sort of stuff. So we put together a cohort, and we're now starting that cohort next week. It's called Get Good with AI. And this afternoon, we're going to run a 1-hour session here, 3 p.m. That's quite soon. So if you want to get good with AI, come and hang out with myself and Shen. We're in one of the rooms upstairs, but it's on the program. Upstairs or outside, wherever they are. Get Good with AI. Ad break over. Nice. Okay, team. I'm coming to you. Maybe I can ask you, I know you've done this under pressure really quickly. Sorry, guys, pop that back on. We weren't talking behind your back. Quick reflection on what you heard, standouts, questions it raised for you. Doesn't need to be a detailed analysis. We're not at due diligence levels, obviously. And then who would you like to see go through to the final tomorrow, and why?
Sorry, I missed the first bit, Ben, so...
Oh, he's putting you on it.
Oh, okay. See how this goes. Yeah, I mean, obviously all fascinating technologies. I think I sort of go third place last. Kazin, I thought it was a fantastic idea. It's a little early for what I would think. I mean, if you can nail that, amazing, absolutely amazing. But we'd need to sort of see a little bit more proof, I think, before making too much. I mean, our due diligence, if it was our company, would be can you come back in a little bit?
Yeah.
We'd be so interested to keep in touch.
And what's your advice, Nick, to companies who are at that level, which is many businesses, and as we were talking about earlier, in the lab it's hard, it costs time and money. Where would you, if that was your business, where are you what's your strategy for funding? Where do you go and look?
If you're super early, it's tough. But I think you've got to be very, very clear on the science, and then you might find a VC who wants to. We try and include a couple of moonshots in our portfolio.
Yes.
So they happen sometimes. That we'd need some level of the science would even need to be a little bit further on. It is tough when you've got a tech risk and everything together risk.
Yeah.
It's risk on risk.
So that's where I think you mentioned, or they mentioned connections to institutions. Here in the UK, our universities are great at incubation, aren't they? A lot of them, and grants can be an option as well.
Yeah, I think it's finding it. I mean, if it's that edgy science, then I think you're bang on the money, Ben. Grants, institutions, angels, early stage. There are people out there. It's tough because institutional tickets. That's just risky.
Absolutely.
Great idea.
Okay, great. On to the next one.
Sorry, this is what happens when you go back to paper, isn't it?
Hey.
So, I'd forgotten how to handwrite properly. So, do you want to hit the next one?
Sorry. My notes as well.
So we had Alexis from SynchroStar and we had Ben from Circular 11. I wanted to ask Ben about what the 11 was. We can tell us afterwards. Yes, Surakat, what have you got? Or Nick, whatever way you want to go.
Yeah, I mean, I think we thought the other two was quite difficult to split between the two of them. I think they're both very compelling businesses, strong IP. I think there's a proven market for their technology, so things that we investors would want to see. I think it looks like a good team in there as well, that's supporting these businesses and developing it with good expertise. And I think I'll let Nick comment on the winner, but I think it was very, very close in terms of what Edge did. But I think these are both strong, credible businesses who are kind of decarbonising sectors that require.
And so, at Green Angel Ventures, when you're in this position where you've got two businesses but you can only afford one ticket, what is often the thing that pushes one over the line over the other?
I think, our core thesis and kind of investor we are is that we want to invest in companies that are tackling climate change, and I think which one is going to have that bigger impact.
So it's the impact metric first over the commercial, or do they have to be side by side?
I think they go along together. So I think if you're going to be a commercial success as a business, it will carry along that impact as well. So I think if you're able to sell, as many of your widgets as possible, that would also, 20 times of that is also 20 times increase in that impact that you're able to have.
Yeah, great. So Nick, who are we going for?
He's going to put it on me. Okay. So we thought by nose it was Circular 11.
Okay. For what, any reason?
No.
No reason.
No, honestly. No, I take it back. I'm joking. I think it's for both of us. It's you've got to. It's like that's a real case of here's some more money, go faster immediately, and I know that's true of both.
Yes.
But much more, a little easier to scale maybe personally. I thought.
Okay.
I had a failed venture into a plastic recycling business, so I have a slight personal bias, but I try to keep that out of it. So,
but it's hard, isn't it, as investors, when you've got that insight and there maybe is some emotional baggage from it, to not pay attention. It either pushes you away or draws you to it, doesn't it? I mean,
usually why we have an investment committee.
Right, so that's
the oversight. Tell me how wrong I am. So,
exactly.
But I personally love it when you see solutions that are like plastic agnostic. We all know it's a wonder material. It's great, but it's the same with fossil fuels, isn't it? They're amazing. They just happen to be rubbish for the planet.
Yes.
So super tough one.
Yeah.
But,
that was great feedback. Thank you. So Ben from Circular 11, congratulations. You're going through to the final tomorrow. Well done. Congratulations to Alexis from SynchroStar and Kaz Industrial for being here with us. Thanks as well to Nick and Surakat for being with us this morning. We're going to have lunch. We're back here for the energy pitches at 2 p.m. So in about 40 minutes. Thanks for being here, everyone. See you soon.